when dealing with graphs in Sage, for instance, here I'm plotting a graph, asking if Hamiltonian, then do the traveling salesman problem, plot it, and actually calculate the sum of the labels in the edges. Let's run it. So we have the result of all that here. First we have the graph as described here, then we have that it is true if Hamiltonian, and here is one possible Hamiltonian cycle here. And then we have the minimal one, and we have how much is the weight of this one. Now, if we try to produce the PDF here, as we normally do, so we will get that Sage takes a long time to generate this PDF. So instead, we are going to change to Jupyter. So we go to here, Jupyter, and here we have our cell, the same one that we have in the Sage notebook. We can just run it directly, and we can see that if we do that, let's run it, we get an error here. So let's see if we can actually do one thing at a time. So first, let's actually just get the graph. So let's delete all these, and let's just run the graph. So here it is. So there is no problem now with the graph. And so in that way, in Jupyter, we're going to be putting one task at a time. So here we have the graph draw. So let's go to the remaining of the sentence here. So in the next one, we are trying to see simple if it's Hamiltonian. So we run it, and it says that it is, and here is the Hamiltonian one. And then we continue. Now let's just plot the minimal cycle here. So we are eliminating this one. We're doing just one at a time. We run it. So here is the Hamiltonian cycle. And so finally we put the last thing that we wanted to know, the weight of this one. So that will be the way to do then one by one. So once that we have now our whole paper in Jupyter, the way to produce the PDF here will be to go to File, and so then in File we go here to scroll until Save and Export as PDF, and here PDF via LaTeX. And so when we click here, so now we'll take less than a minute to get our PDF. So this is the way then to produce a PDF from a Jupyter notebook. So we can see now the PDF from Jupyter.